Okay, before we move on to the next section, let me repeat again. This is the vector equation of a plane. This is one point on the plane, and this is one direction on the plane, and this is another direction on the plane. So as mentioned previously, when the equation of the plane is written in this vector equation form, it is not unique because there can be many different points and many possibilities in terms of the directions. So we have to come up with a different form, which is what we call the scalar product form, or the R dot n form of your equation of a plane. Okay, so to run you through how we actually generate the the R dot n equation of the plane. Okay, we need to go through a few concepts. Okay, the first concept that I want you to go through right now will be the dot product. Okay, so focus on this diagram right here. Okay, this is the diagram I want you to focus on. And this is the normal vector of the plane. And this is one direction vector that's parallel to the plane. B is another direction vector that's parallel to the plane. Take note that vector A is perpendicular to vector n. So if these two vectors are perpendicular, A dot n or n dot A must be equal to 0. Similarly, vector B on the plane is also perpendicular to your normal vector. So n dot B is also equals to 0. Okay, so n is perpendicular, or the normal is perpendicular to two other vectors at the same time. So if we use this theory, okay, let's extend it a little bit further. Let a point on the plane be A. Let another point on the plane be R. So AR, okay, I can find AR via AR is actually perpendicular to the plane. So AR dot n must be equal to 0. And AR actually comes from OR minus OA. So this whole thing, dot with n, must be equal to 0. OR dot n minus OA dot n must be equals to 0. If I shift OA to the other side, I have OR dot n equals to OA dot n. So this is going to be true. And it's going to be true for any 2 points that I can actually find on the plane. So generically, if I can find 1 point, okay, and I say that there's a generic point or arbitrary point R on the plane, I can write down the form of the plane in the R dot n equals to A dot n. Okay, so this is how we actually come about with the scalar product form, or the R dot n equals to A dot n form of your equation of the plane. To run you through this concept, I am going to use example 7 to run you through, okay, because there's numerical numbers. In this question, they ask for the equation of the plane in the form of R dot n equals to P. And this plane contains this point and is perpendicular to this 1 minus 2, 1. So the normal vector of the plane must be this 1 minus 2, 1. And a point on the plane is 1, 1, 3. Remember, this is the form of your equation of a plane in the scalar product form. N, which is here, is 1 minus 2, 1. A is 1, 1, 3. So fitting everything in, I have R dot n equals to A dot n. Right hand side, activate my dot product, I actually get 2. This point, which is your normal vector, stays as it is. And this is your numerical form for your equation of the plane in the scalar product form. Okay, so in summary, to specify an equation of the plane, I will usually need a point on the plane and 2 other vectors that are parallel to the plane. Alternatively, I can also need a point on the plane followed by a vector that's perpendicular to the plane, which we call it the normal. One example, number 8, to run you through again. Find the equation of the plane, okay, in the form of R dot n is equal to P. So I'm giving you the equation of the plane in vector equation form, and I ask you to give me the equation of the plane in the scalar product form, or r dot n equals to p form. So bear in mind, what do you have? I have a point on the plane. I have two directions that the plane is parallel to. So what I'm going to do now is I need to find the normal vector of the plane. The normal vector will come from these two directions. The normal vector is perpendicular to both this direction at the same time. So if I were to do a cross product of the two direction vector, I will be able to get the normal vector. Then the point that I'm going to use will be 1, 0, 0. 1, 0, 0 will be the point that I'm going to use. So r dot n, which is here, r dot n is here, will be equals to a dot n, 1, 0, 0 dot with 5, 8, minus 6. Okay, so simplifying the right hand side, I will get 5. So this is the r dot n form of your equation of the plane. One more example, example number 9. The question asks for the equation of the plane in a scalar product form, and then they tell you that this plane contains this point 1, 0, 1, and this plane is perpendicular to the line with this equation. So this scenario is not so easy to visualize. You need to draw so that you can see things clearly. So draw in everything that you want. Okay, you're supposed to find the equation of plane. This plane pi is perpendicular to the line with equation. So this is your plane pi. This is your line L. This line L refers to this one. Okay, this is the line L. So if you look at the diagram that you actually have drawn, who is the normal vector of the plane pi? Who is the normal vector of the plane pi? L, being perpendicular to the plane pi, have this direction vector. This direction vector will be the normal vector of the plane since it is perpendicular. Next, you must understand, to write down the equation of the plane, I need one point. I need one perpendicular vector. This is my perpendicular vector. Do I have 1 point? 1 point is here. 1, 0, 1. So fit everything into the same formula again. R dot n equals to a dot n. R dot n equals to a dot n. Simplifying it, this will be your scalar product form of your equation of the plane. Okay, so what we have as of now will be two different forms. Vector equation of the plane, r dot n equation of the plane. The next form I'm going to introduce to you is the Cartesian equation of the plane. To write down the Cartesian equation of the plane, you need to start off with the scalar product form first. To do the scalar product form, all I need to do is to replace my r by x, y, z. So what happens on the left hand side now will be x, y, z dot with ABC equals to point P. Activate your dot product, and then I get ax plus by plus cz equals to P. This is the Cartesian equation of a plane pi. One numerical example to run you through. Example 10. I have plane, 3 points, point A, point B, point C. Find the Cartesian equation of the plane ABC. So right now, you must understand question A, Cartesian equation of the plane. So your fundamentals must kick in. To find the equation of the plane, I need 1 point. I need one normal, just to generate the scalar product form first. So draw a diagram. I have point ABC. Do I have 1 point? Yes, it's either point A, point B, or point C. Do I have two directions? Yes, it can be AB, it can be AC. You don't like, it can be BC. You can choose any two directions that you want. So for lecture purposes, I'm using direction AB, I'm using direction AC. AB cross AC will produce a vector that is perpendicular to the plane, which will then be your normal of the plane. This is my normal of the plane. Next, do you have 1 point? So again, I have point A, point B, point C. The choice is yours. Again, for lecture purposes, I'm choosing point A. So r dot n equals to a dot n. So r dot n equals to a, which is 1, 2, 2 dot n. So this is your scalar product form of your equation of the plane. But the question asks for Cartesian equation. How to change to Cartesian equation? Replace your r by xyz. So xyz dot with 1, 1, 0 equals to 3. Simplifying it, you get x plus y equals to 3. This is your Cartesian equation of the plane. Okay, example 11. This time around, I want you to find the Cartesian equation of the plane. From Cartesian equation of the plane, give me back the r dot n form. So all you have to remember is how it comes about. It comes about by replacing r by xyz. So can you do the reverse engineering if I give you something like this? Okay, so what happens now is just have to look at the number, the coefficient, and you just rewrite it as r dot 2 minus 1, 1 equals to 5. And then this will actually give you back the r dot n form of the equation of the plane. Okay, for example A, I also ask you to give me the vector equation. So how to change from this form to the vector equation form? Okay, so this one a little bit different and unique. You need to pay some attention. Okay, so what I'm going to do now is I am going to let x be x and let y be y. So from this original equation, I can rewrite z equals to 5 minus 2x plus y. So the next thing that I need you to do is to write things in a column form. Okay, so what you actually see here is x is just x, y is just y, z is 5 minus 2x plus y. Okay, so when you write things in a so-called column form, I can then just change it into this 5. I just change to 0, 0, 5, and I generate one vector. The x here becomes 1, 0, minus 2, and the y, this column becomes 0, 1, 1. All you need to do now is to replace your x and you replace your y by two different variables, and then you have your vector equation form of your plane. Okay, let's try B again. B, I need you to write this in scalar product form or r dot n form. What to do? Change it into the form containing x, y, z on the left and on your numbers on your right. So it just becomes r dot 3, 4 minus 1 equals to minus 2. Do some practice on your own so that you can understand. Then same thing for this. Okay, keep the x, y, z to the left, number on the right, and then you just replace it by r dot 3 minus 1, 0 equals to minus 1.